Good evening, Doctor. My name is Kevin Lee, and I will be presenting the chapter one for our subject research of methodology. So, the topic for my research is optimization of data center energy efficiency using machine learning. So, the abstract is the purpose of this study is to develop and evaluate on the optimization of data center energy efficiency using machine learning. So, data centers are essential components of modern computing infrastructure, playing a critical role in storing, processing, and managing vast amount of data. However, the increasing demand of the data processing and storage come with a significant energy cost. Data centers are notorious for their high energy consumption, contributing to environmental concern and escalating operational costs. Traditional methods of managing and optimizing energy usage in data centers often fall short in addressing the dynamics and complex nature of the workload and environmental condition. So we gather historical data on energy consumption and environmental condition, server loads, and other relevant parameters within the data center. This problem is to use machine learning techniques such as genetic algorithm and artificial neural network to optimize the energy efficiency of the data center. The outcome of an insights of the machine learning algorithm that can be improved for the energy efficiency of the data center. The result and finding can be presented and discussed using various methods such as table, charts, or case study and validation the model's performance using separate data sets or through a control experiment within a data center to ensure the optimization energy consumption aligned with the desired service set level. So for the introduction, the data center serves as the backbone of the information age, powering a myriad of online services and applications. As the volumes of data processed and stored continues to surge, so does the demand for the energy to sustain this data-intensive operation. So the energy consumption has become a critical concern not only due to its impact on the operation cost, but also because of the environment footprint associated with high power usage. The imperative to strike a balance between the relentless growth of data and the need for sustainable energy efficient practice has led to exploration of innovative technologies. Among these, machine learning has emerged as a powerful tool for optimizing data center energy efficiency. The machine learning leverage advanced algorithm to analyze data patterns, make prediction, and dynamically adapt operation in real time. So this capability makes it an ideal candidate for addressing the complex and dynamic nature of the data center environment. The problem background is in the modern digital economics, the data center are indispensable for supporting the ever-expanding volume of data generated and processed by various online service. However, this growth had come to a cost both in terms of operation expenses and environmental impact. One of the critical challenges facing data center today is the efficiency management of the energy consumption. The demand for computational power driven by cloud services, big data analytics, and emerging technologies like artificial intelligence has resulted in a substantial increase in the power requirement of the data center. The energy consumption of data center is not only a financial concern, but also contributes significant to carbon emission and environmental degradation. Traditional approaches to the data center management often struggle to adapt to the dynamic and unpredictable nature of data workloads, leading to inefficiencies in resources allocation and increased energy consumption. So, for the data, for the problem statement, the data center is very vital in the digital infrastructure, yet the escalating demand for these computational resources had led to a pronounced increase in the energy consumption. So the traditional methods, often relying on static and rule-based system, fall short in adapting to dynamic nature of workload, resulting in subordinate energy efficiency. This inefficiency not only contribute to elevated operational costs, but also the significant environment implication. Recognizing the inadequacies of current approaches, this research as aim to fill the gap by exploring the integration of machine learning techniques by harnessing the capabilities of predictive analytic, anomaly detection, and adaptive control. The study seeks to develop intelligent algorithm capable of dynamically optimizing the energy consumption. So the problem is to enhance data center energy efficiency, mitigating operational expenses and environmental impact, and contributing to the overall sustainable and resilience of the critical infrastructure. So here comes to our research goal, and first thing first is the research objective. The objectives are develop accurate machine learning models for predicting dynamic workload pattern within the data center. The objective is to enable proactive resources allocation and optimizing energy consumption based on anticipated future demands. The second one is design and implement machine learning algorithm capable of dynamically adjusting resource allocation in response to real-time workload variant. And the aim is to enhance server utilization, minimize idle capability, and reduce overall energy wastage. And the third one is utilize machine learning to optimize the cooling system by analyzing temperature and environmental data. The goal is to maintain optimal operating condition while minimizing the energy consumption associated with the cooling infrastructure. And the fourth one is apply machine learning approaches to predictive renewable energy availability, allowing the data center to align operation with sustainable energy sources. The goal is to reduce reliance on the non-renewable power and promote environmental conscious practice. So what are the research question is the first one, how can machine learning models be effectively employed for predicting dynamic workload pattern within the data center, and how does this predictive capability contribute to proactive resource allocation? The second one, what machine learning algorithms are suitable for dynamically adjusting resources allocation in response to real-time workload variation, and how do these algorithms impact the server utilization and energy wastage? In what way can machine learning techniques be applied to optimizing cooling system by analyzing temperature and environmental data? And what are the implications for maintaining optimal operating condition while minimizing the energy consumption? And the fourth one is, how can machine learning models effectively detect anomalies in energy consumption patterns, enabling an earlier identification of potential hardware issues and contributing to timely maintenance to prevent system failure? So here comes to the scope and limitation. This research aims to explore and implement machine learning solutions for optimizing data center energy efficiency across the diverse environment. So we focus mainly including developing models for predictive analytics, data resources and allocation, cooling system, optimization, anomaly detection, and renewable energy integration. The study encompassed various data center type, workload pattern, and environmental condition, emphasizing the practical applicability while efforts will be made to address real-world implementation challenges and economic consideration. Limitation may arise because of the data sensitivity, complex workload scenario, and resources constraint. Generalizing all the data center environment may be limited, and the adaptability of models to unforeseen environmental factors and long-term sustainability assessment might face constraint. Recognizing these factors is essential for providing nuanced insight into the applicability and potential challenges of machine learning-driven energy efficiency optimizing in data center. So the significance of the study lies in its potential to revolutionize the data center operation by harnessing the power of machine learning for energy efficiency optimization. As the demand for computational resources continue to grow, the data center may facing elevated energy consumption, make the sustainability a paramount concern. By delving into predictive analytics, dynamic resources allocation, and cooling system optimization, the research aimed to offer practical solutions that could lead to sustainable reduction in energy usage, translating into significant cost saving for data center operator. So the integration of renewable energy sources into the operation framework align with global environmental goals, marking a progressive step towards greener and more sustainable data center practice. Ultimately, the successful implementation of this innovation has the potential not only to advance academic understanding, but also to serve as a model for industrial-wide adoption, paving the way for more sustainable and economically efficient future in data center management. So for my thesis structure, there will be 5 chapters. The first chapter will include the overall introduction to the research. Chapter 2 will discuss more on the literature related to this research and narrow the topics to end with the research gap. And the chapter 3 is discussing more on the research methodology, and chapter 4 will show how the data was collected and analyzed, and the chapter 5 will conclude the research and pave the way for future work. So the summary is this research focuses on addressing the critical challenge on suboptimal energy efficiency in data center, leading to increased operational cost and environmental impact. Recognizing the limitation of existing approaches, the study proposed innovative solution through the integration of machine learning techniques, leveraging predictive analytic, anomaly detection, and adaptive control. The research aimed to develop intelligent algorithm capable of dynamically optimizing energy consumption in data center. The successful implementation of machine learning hold the potential to revolutionize data center energy management, offering a more adaptive and sustainable approach to address the multifaceted challenges faced by this critical infrastructure.